Welcome to This Explainer. Look, if you're a new career starter staring down the massive, incredibly fast-moving universe of artificial intelligence and machine learning, you are probably feeling a wild mix of excitement and, let's be honest, total overwhelm. I mean, where do you even start? Well, today, we're going to help you architect your intelligence. We're actually going to treat this whole career path like a culinary journey. We'll take you from an absolute beginner who's just learning how to hold a chef's knife, all the way to a master chef running a flawless, production-ready Michelin star AI kitchen. But first, let's talk about taking that daunting leap into AI. Because as a beginner, there's a pretty massive gap between expectation and reality. The expectation is usually that, on day one, you'll be coding up the next sentient robot or some conversational masterpiece. But the gritty reality? Before you can cook a masterpiece, you really have to understand your raw ingredients. And in this world, that means we have to start with foundational math, rigorous data cleaning, and some serious prep work.
So here is our roadmap. We're going to break this massive field down into 5 digestible steps. 1. Math concepts. 2. Data and code. 3. Classical ML. 4. Deep learning. And 5. Production.
Let's dive into Section 1, the foundation, which is math concepts. Before you ever touch a stove or write a single line of code, you have to understand the fundamental flavor profiles of your kitchen, and that is mathematics. The very first essential concept is linear algebra. Now, if you're an absolute beginner, terms like matrix operations or vector spaces might sound completely terrifying. But I really just want you to think of linear algebra as the math of representing and organizing data. It's exactly like organizing a massive commercial pantry perfectly. You need to know exactly where all your ingredients are, how they group together, and how to grab them instantly. Without linear algebra, your data is basically a chaotic mess spilled on the floor. With it, your data is beautifully structured, transformed, and ready for the machine to use.
Our next foundational pillar is calculus, specifically things like differential calculus and partial derivatives. Now, why do we need this? Because calculus is essentially the math of optimization and rates of change. In machine learning, we use optimization algorithms, like gradient descent, and you can think of gradient descent exactly like adjusting an oven's temperature. If your cake is burning, you turn the heat down. If it's undercooked, you crank it up. Calculus gives the algorithm the exact, precise mathematical instructions on how to adjust its internal weights to get the recipe absolutely perfect.
And rounding out your foundational training is the rest of your essential math and stats toolkit. We're talking probability distributions, Bayes' theorem, hypothesis testing, and loss functions. Just think of these as the crucial tools that help you make smart, calculated decisions, rather than just blindly guessing in the dark. They tell you the exact probability of a recipe succeeding, and they measure precisely how far off your current dish is from perfection.
All right, moving on to Section 2, prep work with data and code.
So an ML engineer isn't just a mathematician. You have to be a highly capable software engineer too. This is where you really develop those essential knife skills. And here's a little industry secret about the reality of the job. You are going to spend about 80% of your time chopping onions. And by that I mean cleaning messy data. As a budding engineer using Python, which is the absolute industry standard, alongside libraries like Pandas and databases using SQL, you'll literally spend hours crying over missing data, outlier detection, and normalization. Your data pipelines have to be perfectly prepped before you can actually start cooking anything meaningful. Because remember, if you put garbage ingredients in, you're getting a garbage meal out.
Which brings us to Section 3, basic recipes, or classical ML.
This stage is all about mastering your classic, foundational recipes before you ever attempt those experimental avant-garde dishes. What's cool is how clearly these classical algorithms map directly to highly practical, real-world business problems. We generally look at 2 main types: supervised and unsupervised learning. Under supervised learning, you've got regression algorithms like linear regression, which is perfect for predicting a specific number, like predicting future house prices. Then, under unsupervised learning, where the data isn't labeled for you, you have clustering algorithms like k-means. This is incredibly useful for grouping similar customers together for a big marketing campaign, even when you don't know in advance who belongs where. Mastering these classic recipes is what builds your intuition for the heavy-duty stuff later on.
Let's step it up in Section 4, advanced cooking with deep learning and modern AI.
Once you've got the basics down, it is time for the molecular gastronomy of our kitchen. This is where we handle unstructured data, stuff that definitely doesn't fit neatly into a spreadsheet, like text, images, video, and audio. To work with this, you need seriously powerful tools. You'll start building complex, multi-layered architectures known as neural networks. Using frameworks like PyTorch and TensorFlow, you'll build convolutional neural networks, or CNNs, which basically act as the eyes for computer vision tasks, like object detection. You'll also use recurrent neural networks, or RNNs, which handle sequential and temporal modeling. That makes them perfect for time series data or foundational text processing.
And as you advance, you'll eventually get to play with the absolute heavy hitters of the current state-of-the-art. We're talking about transformer architectures that use attention mechanisms to build massive large language models. You'll explore generative AI like diffusion models for text-to-image synthesis. But honestly, more importantly for your actual career, you're going to learn adaptation techniques. Using methods like RAG, which is Retrieval Augmented Generation, and LoRA, you'll learn how to take these massive general-purpose foundational models and fine-tune them so they fit highly specific, highly valuable business contexts.
Finally, we reach Section 5, moving from notebook to production.
This right here is the absolute most critical transition for any career starter. It's the ultimate upgrade from cooking a nice meal at home for fun to running a massive, high-volume Michelin-star restaurant that serves 10,000 customers a day without a single mistake. Imagine you built a brilliant machine learning model locally on your laptop in a Jupyter notebook. It predicts perfectly. Now what? How does a real customer actually use it? Making an algorithm work once locally is an entirely different beast from deploying professional, production-ready software that the whole world can interact with.
So here's the ultimate reality check for your career. Building the model itself, that's really just 10% of the battle. The other 90% is MOps, or machine learning operations. Bringing a model to production, keeping it totally reliable, scaling it, and monitoring it, that is where your real value as an engineer actually lies. Because at the end of the day, businesses don't pay for notebooks, they pay for deployed software.
This MLOps lifecycle represents the exact operational steps you need to successfully ship your models. First, you've got version control, using Git to meticulously track your code changes. Second is model tracking, with tools like MLflow to register your experiments and hyperparameter tweaks. Third is containerization, using Docker. This packages your model so it runs perfectly on literally any cloud platform, serving it up via REST APIs. And fourth, monitoring for drift. Data out in the real world changes over time, right? Monitoring ensures your model's performance doesn't randomly degrade. This operational pipeline is exactly how you keep your restaurant running flawlessly, serving thousands of digital dishes every single second.
And there you have it. We've covered the entire journey. We've demystified the foundational math, we've chopped the messy data onions, mastered those classical recipes, explored the molecular gastronomy of deep learning, and finally laid out the critical operational path to actual production deployment. You literally have the complete blueprint right here to architect your intelligence and launch your career. The only question left to ask is, with all these incredible tools now at your disposal, what are you going to build first?